All right, so we're back to computing a couple examples of standard deviation. We've already computed a couple with mean of where we had samples with a mean of 5 and we had 10 values. So we're going to keep going with that because we want to look at different comparisons here. So here is another set of 10 values. So I'm just going to write over here n equals 10. And probably no surprise, but if you add up these values, you do get 50. Which means that the mean is 5 once again. So, but again, notice that these values seem to be more clustered close to the mean. In fact, these 6 values right here are all equal to the mean. So that's going to mean something to us too. So let's just let the numbers tell us what the story is here. So if I subtract 5 from every data value, well, that means this is going to be -2. There's going to be -1, and we're going to have 6 zeros in a row. And then we're going to have, so 6 minus 5 is 1, and 7 minus 5 is 2. But remember, the standard deviation formula says to square the deviations before we add them. So that's why we have this third column here. So -2 squared is 4, -1 squared is 1, and 0 squared is 0. And we have 1 and 4. So the standard deviation is the sum of that third column, which is 10. So SD is equal to square root. The sum of that column is 10, and n minus 1 is 9. And again, running to the calculator, we have the square root of 10 over 9, which is 1.054. So it's kind of small compared to the others. So that further emphasizes that if you have values that are closer to the mean, your standard deviation is going to be smaller. And if you have values, so as you have more and more values that are further away from the mean, that's going to cause your standard deviation to increase, which is why outliers make the standard deviation increase, because they're really, really far away from the mean. They're far away from everybody else too. So that's the story with that one. So we're starting to see this pattern here. Let's look at one final example, and notice here, all values are the same. Now that automatically says, well, let's see, that means the total here is 50. Again, we have 10 fives, which is 50. So, shocker, the sample mean is 5. Now, let's look at the deviations and the squared deviations. Well, the deviations, if I subtract 5 from 5, I get 0. So all my deviations are 0. In fact, I'm not even going to bother writing them down. I was going to do zeros all the way here. When you square 0, you get 0. So again, zeros all the way. And if I add up that third column, just like we've been doing before, that's 0. So that means that the standard deviation is the square root of the sum of the third column, which is 0, divided by n minus 1, which is 9. And no calculation necessary. That's the square root of 0, which is 0. So we can generalize that. What if all those values had been 15 or 25 or 31.2, whichever? If all the values are identically the same, the standard deviation is going to be 0. So that's one important thing to get out of this. The standard deviation is going to be 0 if all the values are equal. And if you think about it, it makes sense. The standard deviation is kind of the average deviation that something is from the mean. So if I take all the deviations and average them, you kind of get close to the standard deviation as long as you only add up the positive versions of those. And so if nothing ever changes, the standard deviation is going to be 0. So that's why standard deviation is a measure of variation. So if standard deviation increases, we have more variation. So what does standard deviation mean? Well, we're going to look at a couple things where we can use standard deviation to solve some real world problems. So hopefully you come back for that. I thank you for watching, and I hope this helped you.